Hello and welcome to Kashmatics. In this lesson, I'm going to show you how to differentiate an implicit function. But before I do that, I'm going to explain what an implicit function is so you can recognize one when you see it. Now you're also going to need to know how to use the product rule, the quotient rule, and the chain rule. So if you've got no idea what those are or a bit rusty on those, then please go and watch my tutorials on those first. Anyway, grab yourselves a pen and some paper and let's crack on. First of all, we need to understand the difference between an implicit and explicit function. So on the left here, we've got some examples of explicit functions. Now, if y can be written explicitly in terms of x, okay, so y is some function of x, then it is said to be an explicit function. So all of these on the left are explicit functions. Y is written in terms of x, okay, so you've got y on one side and then a function of x on the other side. Now on the right hand side over here, it said if y is not written explicitly in terms of x, for example, some function of x and y equals 0, then it's said to be an implicit function. So if you look at the first one here, you've got 2x plus 3y minus 7 equals 0. The second one is an equation of a circle, and that's x squared plus y squared is 25. So it's a function of x and y equals something else. I know it said equals 0 here, but these can all be rearranged to make them equal 0. And the last one here, we've got a function of x and y which equals 0. Now sometimes what you can do is rearrange an implicit function to make it explicit. So this first one here you might recognize as the equation of a straight line. And I could rearrange this to make y equals mx plus c and then just differentiate it as normal. This second one here, I could rearrange it to make y the subject. Okay, and I'd get y equals 25 minus x squared and all of that gets square rooted. Again, I can deal with that just as I would with a normal explicit function, but it's actually easier to deal with it as an implicit function. And this last one simply can't be rearranged to make y the subject, so I have to use implicit differentiation. So now you know what an implicit function is, let's go ahead and try to differentiate them. Now the first thing I need to understand is how to differentiate terms with a y in them. Okay. Now you deal with these in exactly the same way as you would with terms with x. Now remember here what we're doing is we're differentiating with respect to x like we do with a normal function. Now just like with x becomes 1, y also becomes 1, but what we need to do is hook on a dy by dx. So it becomes 1 dy by dx, which we just normally write as dy by dx. Okay, so y becomes dy by dx, and that kind of makes sense because if I had a function like y equals 3x squared, when I differentiate the whole of this with respect to x, the y does become dy by dx, and this would become 6x. Okay, so you should already be used to knowing what y becomes. You probably just haven't thought about it in that way. So 3y squared, remember you multiply by the power, then take 1 off the power, so that would be 6y. We just got to remember to hook on a dy by dx. Okay, so it's just like normal differentiation, apart from the fact that you've got to hook on a dy by dx. E to the power 4y will become e to the power 4y times by 4. Then hook on your dy by dx. Cos of y squared. Now cos something becomes minus sine something, so it'll be minus sine of y squared. Then have to remember to multiply by the derivative of y squared, which would be 2y dy by dx. Okay, and then I can just tidy that up a little bit. And ln 6y, ln becomes 1 over, so it'd be 1 over 6y multiplied by the derivative of 6y, which is 6 dy by dx. So that 6 can cancel that out, and then you can tidy that up. Okay, so the main thing to remember here is you differentiate as normal. All you have to do afterwards is hook on a dy by dx, and that's that sorted. Okay, so if you need to make that note in your notebooks, then please do so. Now this first example is the easiest type you're going to get, and that's because the y term is completely separate from the x term. Alright, so let's just see what we have here. So 4y squared, let's differentiate that as normal, so that becomes 8y, and then dy by dx. Remember, anything with a y in it, you need to hook on a dy by dx, plus x squared just becomes 2x equals 6. Okay, so hopefully these two terms were simple enough for you. Right, and all I need to do now is just rearrange this. So dy by dx equals, now I'd do 6 take away 2x, and then I'd have to divide by 8y. Okay, so you can see here that the derivative is actually in terms of y and x. Okay, and that's what you normally end up with when you're doing implicit differentiation. In this second example, I've got a bit more going on. The first term you should be able to deal with now, but the second term is actually a product. All right, so what we need to do is apply the product rule. So if I say let u equal x and v equal y. Now remember, when you're applying the product rule, you have to differentiate each of these. So du would equal 1 and dv would become dy by dx. Remember, y becomes dy by dx. Right, so let's put all of that over here. So I've got 6y cubed, which becomes 18y squared dy by dx. Don't forget to hook on the dy by dx. That's something which a lot of people tend to forget. Plus, now remember the product rule is u dv plus v du. So x multiplied by dy by dx, x dy by dx, plus v du, which is just y, equals the derivative of x squared, which is 2x. Okay, and the other thing that people do tend to do is forget to differentiate the other side. Anyway, we need to rearrange this to make dy by dx the subject. I've got two terms with dy by dx, so we need to factorize that out. So dy by dx, open your brackets, 18y squared plus x. And whilst I'm at this, I'm going to move this to the other side. So 2x take away y. And now I'm going to divide by this inside the brackets. So dy by dx equals 2x minus y over 18y squared plus x. This next example, again, we've got a product over here. This is a term with just y in it. Here we've got an exponential term, and here we've got a constant. Okay. Now, before I differentiate, always look to see what I'm dealing with. Okay. So take your time to make sure you know how to deal with every term, and then go ahead and do it. So let u equal 5x squared and v equal y. Du would equal 10x, and dv would equal dy by dx. Okay, let's put it all together then. So the product rule first. So u dv, 5x squared dy by dx, add v du, so 10x times y, so 10xy, plus this becomes 15y to the power 4 dy by dx. Okay, always remember to hook on your dy by dx, equals e to the x, which is just e to the x, and the 4 disappears. Okay, so I've got dy by dx twice like I did before, so I need to factorize that out. So dy by dx, 5x squared plus 15y to the power 4 equals e to the x. I'm going to take away this 10xy, so minus 10xy, and let's divide by everything inside the brackets to give us e to the x, take away 10xy all over 5x squared plus 15y to the power 4. Now in this next example, you might be tempted to use the quotient rule because you see a division on the right hand side, but you don't actually need to. What you can do instead is multiply by that denominator to get rid of it. So you've got x squared minus y equals 2y, and let's expand this, and you get x to the power 3, take away xy equals 2y. So what you end up with is a nice easy term over here, a nice easy term over here, and we've got the product rule going on over here. But because this minus, I need to be a bit more careful. I need to watch my signs. So just as before, let's just sort out this product first. So if I say u equals x and v equals y, du equals 1 and dv equals dy by dx. All right, so x cubed becomes 3x squared. Take away, now I'm going to put all this in brackets. U dv, so x dy by dx, plus v du, which is just y, equals the derivative of 2y, which is 2 dy by dx. Remember, 2x would have just become 2, so 2y becomes 2, then dy by dx. Right, so what I'm going to do here now is I'm going to expand the brackets, and then I'm going to put it all together. So 3x squared, take away x dy by dx, take away y, equals 2 dy by dx. Now it doesn't matter which side you want the dy by dx to be on, but I tend to keep it positive. So I'm going to keep everything on the right hand side, that's with dy by dx, and everything else on the left. So rearranging this, I'm going to get 3x squared minus y equals 2 dy by dx plus x dy by dx. And now I'm going to factorize out the dy by dx. So I get 3x squared minus y equals dy by dx, open brackets, 2 plus x. and then I'm going to divide by 2 plus x. Now at this point I'm going to just write it the other way around because that's how I like it. So it's going to be 3x squared minus y over 2 plus x. Right, in this next example, we've actually got two products. Okay, we've got a product on the left and a product on the right. So we've got two of those to deal with. So let's deal with the one on the left first. Okay, so let u equal e to the power x and v equal y. Du equals e to the power x and dv equals dy by dx. Now on the right hand side, now I'm not going to call it u and v because I've got those over here. Let's call it something else. So p and q. Okay, let p equal x and q equal e to the power y, and dp would equal 1 and dq would equal e to the y dy by dx. Alright, so you cross multiply for the product rule. So let's do the left hand side first. Now I'm going to have to be really careful because as you can see you've got a lot of terms here which are very similar, and if you're not careful you're going to end up mixing these up. So let's do the left hand side first. So u dv e to the power x dy by dx plus v du, which is y times e to the power x, equals p dq plus q dp. Now that doesn't roll off the tongue as easily as u dv plus v du, but if you want to, well, fairly easy tongue twister, there's one for you. Right, okay, e to the power y x, or x e to the power y dy by dx plus e to the power y. Okay, so as you can see, there's lots of terms which are very similar here, so I've got to be careful. Anyway, what I'm going to do is what I did before. So everything with a dy by dx, I'm going to put on the left-hand side. So e to the power x dy by dx, take away x e to the power y dy by dx equals e to the power y, take away y e to the power x. And then I'm going to factorize that dy by dx. So that's going to be e to the x take away x e to the y equals e to the y take away y e to the x, and then I'm just going to divide by this inside the brackets to get the final answer. So dy by dx equals e to the power y take away y e to the power x all over e to the power x take away x e to the power y. And on to our final example. This one looks a little bit trickier than it actually is, or maybe it doesn't look tricky to you, I don't know. But it's the term on the left that might catch people out. The ones on the right are dead easy, it's the one on the left. Now all you've got to do here is use the chain rule, but with implicit differentiation going on inside it. Okay, so anything to the power 4 will become 4 something to the power 3. Okay, so that's how we start this. It'll be 4x minus y to the power 3. But then we have to multiply by the derivative of what's inside the brackets. So let's open our brackets, because the derivative of this is 1 take away dy by dx. Alright, so hopefully you've understood why that is the case. Equals x, which just becomes 1, plus 3y, which becomes 3 dy by dx, and the 6 disappears. And what we do next is just expand these brackets, but I've got to be careful. Okay, so this is going to be 4x minus y cubed. I'm not expanding these brackets, I'm expanding these ones, okay? So all of this gets multiplied by 1, take away all of this being multiplied by dy by dx. So 4x minus y cubed dy by dx equals, let's write this a bit neater, 1 plus 3 dy by dx. Now I've got terms of dy by dx on both sides, and this one's a negative term, so I'm going to move it to the right hand side and move this 1 over to the left. So I get 4x minus y cubed take away 1 on the left equals 3 dy by dx plus 4x minus y cubed dy by dx. Alright, so I've got two terms with dy by dx over here, so let's factorize that. Okay, so 3 plus 4x minus y cubed. And on this side I've got 4x minus y cubed take away 1. So all I need to do now is divide by this term over here. Alright, so I end up with dy by dx equals 4x minus y cubed take away 1 all over 3 plus 4x minus y cubed. Okay, and hopefully that's made sense. If it doesn't, then go back and watch it again. It's this bit here which is going to catch you out, if anything, because that is the derivative of what's inside the brackets. But anyway, as far as implicit differentiation goes, that's all I've got to show you. Okay, in the next video, I'll be showing you how to use rates of change to calculate real life problems. But until then, thank you for watching, or thank you for listening, and I'll see you next time. Goodbye for now.